keeping it upright, can't you? Psh. No, it's interesting. They haven't really given us much in terms of updates because you guys do know what's happening in less than 2 weeks, right? There you go. Yeah. They're going to be transitioning us to the full-time school to 2 o'clock.
2 o'clock? Wait, what?
Or 1:50, really. Yeah, you're right. 1:50, 2 p.m., potato. You know, it's written the same on the card. Yeah, it did. Now, they haven't really given us much in terms of like policies or advice, or like they're just like, well, 4 minutes for this, or this, or this, or this, but we're going to decide. Just give us some like straightforward information. Like what is one updated piece of information? I think during the beginning of last week, they said that if you were fully vaccinated and you left the state for personal reasons or whatever, then you didn't have to quarantine when you came back. That was the only updated piece of information they gave.
So you just don't tell people.
No, I know. But then like there has been like legal questions in terms of like, okay, if you leave the state and then come back and don't quarantine and continue your normal work life, let's say, you develop symptoms and then end up spreading it to someone else. Well, New York isn't on that travel ban.
What is?
Anything outside of the tri-state area. I think Connecticut, maybe. Yeah. Even though it's 4 states, technically it's the tri-state area, you know. Anyway. But yeah, I mean, technically speaking, like if you develop if you develop the virus and then spread it to someone else, but then it's just like, oh, like, you know, they found out you're traveling beforehand, that could be considered like negligent, you know.
How did they know that?
No, I'm just saying if eventually an investigation was done, because they have to investigate like the contact spreading. You know what I'm saying? I'm just saying there's always like a little loophole right there. Just saying. Well, regardless of what people think about it, I'm just saying about the legal ramifications. But I'm saying that they put out the new policy saying that if you're fully vaccinated and you travel out of state, then you don't have to quarantine for those 2 weeks. Like, that's cool. Anyway, but we're here. April 1st was the end of the third marking period. April 1st was the end of 75% of the school year. Now, I put a note, or I posted a note on Google Classroom on April 2nd, saying that, well, yes, grades have to be submitted by April 15th. If you owe me anything, then we can take care of that before April 15th. That would be fantastic. In fact, as a bunch of people found out yesterday, I updated a bunch of grades. I haven't updated everything yet. I have not updated everything yet, but I have updated a bunch of stuff that people sent me over the course of break. And I'm still continuing to do that because obviously I have until Thursday the 15th. I would not wait until Thursday the 15th because I believe that I have to be submitting grades by 8 a.m. unless they decide to change that, which I don't know if they will. So that's why I'm saying get it to me before then. Today's the 13th. Tomorrow's the 14th. Get them done. It's going to be nuts. It's going to be crazy. It's going to be amazing. But anyway, I think, do you guys have off Monday? I believe so, right? It's it's a staff PD day, no students. No, that's January. Yeah, that's April. Yeah. So I have you this week, Tuesday, Thursday, and then I would have you Monday, but then I think I'm going to have you Tuesday, Thursday of next week as well. But we'll figure that junk out when we get there. In the meantime, before we left for break, now, this is going to be a little weird, but before we left for break, do you remember what we did? That's not exactly what we did. You remember the benchmark? Yeah, we took the benchmark before we left on that Thursday. On that Tuesday, we reintroduced, well, actually, no, before that Tuesday, on that Friday before we reintroduced factoring. And then on that Tuesday, we went through a bunch of problems in which we had to simplify rational expressions. Now, what I'm about to give you is kind of like a cold call almost. It's will not count against you. It is a practice. I want to knock out a quizzes. This quizzes will be about simplifying rational expressions. And I want to see what you can do with it. If you do not already have out those Chromebooks, I'm going to ask for those Chromebooks to be out and ready to go, logged on, before I actually give you the code that's up here. If you are in the chat, which before it was like 6 or 7 people in the chat, now it's down to 4 people in the chat. But if you would have your Chromebook ready to accept whatever quizzes code I'm going to be throwing at you in a few moments. Question? Real quick before we get started. Now, mind you, even if we get started before you get back, you can still join with the code. But let's get those things ready to go while I bring that code up. Let's see here. Simplifying rational expressions. Now, these questions, it's a very short quizzes. It's 10 questions. Classic. Let's see here. Yep. And yeah, I'll keep redemption questions on there. It seems people like the redemption questions, but they don't like the power-ups. You know? A little weird. The power-ups, like, people just don't like them. They don't know when to use them, or some of them are useless. You know? But anyway, for those of you in the chat, here is the code. Obviously, you can see it. Well, kind of. It's 434123. I'm sorry, 343. Oh gosh, too many threes. But yeah, I typed it into the chat so you can see it there. I want you guys to be joining that thing. That would be fantastic. I would strongly suggest a scratch piece of paper, just in case, because some of these problems you may have to scratch out some factoring. It has been over 2 weeks since you have seen anything like this. So I expect that there's going to be some gaps, but I need to see where these gaps are. Again, this will not count against you. But let's get logged on as quickly as we can. Ba-da-ba-da-da-ba-da-ba-do. If you haven't logged on, make sure that you do. Obviously, I'm going to be wandering around. For those of you in the chat, again, even if you don't log on by the time this starts, the code will be at the top. It's also in the chat. Let's get it started. They're spying on us. For you guys that are wrapping up, I'm going to give you about another minute or so. And then I would like to definitely go over some problems with you. end it there. All right. So, here's my plan and objective for today. Number one, it's been a couple weeks since we've seen this information. So I want to spend some time going over the most problematic problems that we have seen on this particular quizzes, because there are some deceptive trips that they planted for you. After that, I would like to take a step towards the next, well, I don't want to say the next level, but I want to take a little step further into this whole idea of simplifying rationals. So what I'm going to ask you to do, you do not need your Chromebook if you are in this classroom. You do not need your Chromebook for the next part of this class period. I am going to be putting problems up from this quizzes, but I am going to be writing them into my notes. So what I'm going to ask of you, if you do not already have them out, I'm going to need those notebooks out and open. Let's see what we got here. Now, for those of you in the chat, I can see the chat right here. I have it on my phone. If you do have any questions in regards to it, that'd be great. In my notes, I am going to be putting the following. Today is the 13th. This is simplifying rationals practice. Before break, I reintroduced you to a concept of factoring, and I showed you a variety of problems in which factoring can be used to simplify. Now, with these problems, the main objective was multiplication and division of fractions. And that is what this quizzes was about, the multiplication and division of fractions. That step further that I talked about is going to go beyond that, but we'll get there when we get there. For right now, I want to take a look at these questions sorted by accuracy. Let me go down to the bottom. And I'm going to write down the first problem, and then I'm going to show you what it should have been. This is from the quizzes. It was x squared minus 7x plus 10 divided by x squared minus 8x plus 15. That is what I wrote down. And I would have you write down the same thing. That would be fantastic. This is from the quizzes. Couple of reminders. First and foremost, oh, Mr. Rocky, look, those x squareds. I want to cancel out those x squareds. You can't. You can't. You cannot cancel out those x squareds. Why not, Mr. Markey? It's x squared divided by x squared. Well, because there are subtraction symbols separating these x squareds from the rest of the problem. Something that I mentioned before break and something that we reiterated was that you can only cancel stuff out like that if what is separating them is nothing more than multiplication or division. It has to be multiplication or division. If there is addition or subtraction separating a term from the problem, then I'm sorry, you cannot cancel them out the way that you want to. You can't. You cannot just cancel them out and make them a 1. Sorry. Instead, I need you to think and realize that there are parentheses around the tops and bottoms of this fraction. There are parentheses there. And because of that, well, it's a single equation, a trinomial per se, divided by another trinomial, and they do not match each other. But I can factor. I can factor. Now, again, I mentioned the Tucker method of factoring. I'm going to be doing a modified version of the Tucker method of factoring because this is a 1x squared and 1x squared. Because it's a 1x squared and a 1x squared, I can do this modified version. Can you give me two numbers that multiply to 10, but add up to -7? Yeah, close. They both have to be negative. No, it's all right. But I'm saying that's a common, like, little, like, that's a huge thing because they both have to be negative to multiply to be a positive, the positive 10, and they both have to be negative to add up to that -7. -2, -5. So then I asked the same question for the bottom. What about two numbers that multiply to 15, but add up to -8? Ooh. In this case, they both have to be negative once again. They have to multiply to be that positive. -3 and -5. X minus 3, X minus 5. Your first objective would be to factor. Factor, 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 factor. Greatest common factor, Tucker method of factoring, whatever method of factoring that you've learned in the past. Somebody yesterday talked about some. You guys ever learn this thing where it was like an X or some junk like that? Yeah. And that's fine. If that works for you, show me the work. You can do that method. I'm fine with that. You don't have to do my method, but you have to be able to back it up. You have to be able to back it up with work and not just whatever photomath told you, whatever websites y'all use. But now here's the deal. Oh, she says it in the chat. It was -5, -3. I see you there, Kelsey. She's talking in the chat. She and I are having a conversation. Anyway, X minus 5 is a single term that is being separated from the rest of the problem by multiplication and division. And because it is only being separated by multiplication and division, this X minus 5 and this X minus 5 cancel each other out, leaving you with X minus 2 over X minus 3. That has to be the simplified version of this problem. Now I'm going to go back to the quizzes and see what answers you all chose for that, because I want to see what most people chose, because this was the most difficult problem according to quizzes. According to quizzes, we got the least percentage correct on this one. Let me check that quizzes. Okay, it looks like most people were spread out amongst the first, second, and fourth response. But as you can see right there, the green one, X minus 2 over X minus 3. Interesting with the ones there. Yeah, we'll see what happens. Let me go back a question now. Oh, here we go. The second most difficult problem of the day. I'm going to write this one down. Next example. 7m plus 42 divided by m squared plus 3m minus 18. Flip. There we go. There it is. There is the problem that is haunting us. It's got to focus. There we go. Now I look at this problem. Yes, it has m's and not x's. No big deal. What's so different about what's on top of the fraction versus what's on bottom of the fraction? What is so different about the top of the fraction versus the bottom? Because there's a glaring difference that I need you to recognize. What does one side of the fraction have that the other side doesn't? Yeah. This bottom is a quadratic. It has an m squared. This top is not quadratic. It's linear. The top of this fraction, you cannot factor like a quadratic. You can't. You cannot factor using the Tucker method. You can't. Instead, oh, she said in the chat, I see you there. She said the bottom is a quadratic. But on the top of this fraction, since it is not a quadratic, we can still factor it with 3 simple letters. What are those 3 letters? We can still factor the top of this fraction with 3 simple letters. What are they? Ooh. Yeah. There it is. We can still factor it. We just can't do the rest of the Tucker method because it's not a quadratic. But we can take out a 7 as a greatest common factor. We can take out that 7, and we're left with m plus 6. The top is factored. Done. That's the top of the fraction. Now, we're not done with the problem, but that's just the top of the fraction. On the bottom of the fraction, we can go about the regular Tucker method that we have been doing, or whatever method of factoring strikes your fancy. I need 2 numbers that multiply to negative 18 and 2 numbers to negative 18 and add up to 3. Positive 3, that is. Give me any 2 numbers that multiply to 18. 6 and 3. Make one of them negative. Sure. M plus 6, M minus 3. They multiply to negative 18. They add up to positive 3. Now, mind you, you are only allowed to do it that way if the leading term is a 1 or a 1 variable squared, 1x squared, 1m squared, whatever it ends up being. But now, those m plus 6s, yes. Those m plus 6s, because they are only separated by multiplication or division, can cancel each other out, leaving you with 7 over m minus 3. That is what the answer is. That is all that we can do to the problem. There's nothing more we can do to simplify this particular problem. These are the tactics that we would have to have in order to simplify problems like this. I have one in mind that I want to try, but I want to see what else is on here. Okay. And that one. And ooh, that one. Maybe I'll come back to that one. Oh, nope. We're definitely doing this one. Yep, we're definitely doing this one. Okay. Cool. Let me write this one down. And then I have one that's not on the quizzes, but we're definitely going to have to do this one. The example being 5x squared plus 11x plus 6 over 5x squared plus 14x plus 9. Yeah, there it is. There is the problem right there. I think this might be the last one from the quizzes that I want to try. I do have a few other sample problems in mind. Yeah, I think this is the last one from the quizzes that we're going to try. Click. There we go. But definitely this example. Now, I can't do this problem the same way I did the previous ones because they both lead with a 5. They both have a 5x squared there. Ugh. So instead, I'm going to have to go through a little bit of the Tucker method in order to get this problem done. So first, let me start with the numerator. 5, 11, and 6 have nothing in common other than 1. A times C. Now, this is going through the Tucker method. A times C is 30. 2 numbers that, well, that's kind of coincidental. That's not even a word, coincidental. It's coincidental. What are my magic numbers here? What 2 numbers multiply to 30 and add up to 11? Yeah, that's what the heck. I just had 5 and 6, right? 5 and 6. You need a T chart. Put the numbers in the bottom of the T chart. A 5x and a 5x. This is walking you through the Tucker method with the numerator. 5 over 5 simplifies to be 1 over 1. You end up with an x plus 1 and a 5x plus 6. This is the Tucker method that we have been doing since the beginning of the school year. I can do the same thing with the denominator. 5x squared plus 14x plus 9. Step 1, take out a GCF. Oh, the GCF is 1. Okay. Step 2, multiply. What is that, 45? 5 times 9 is 45? Yeah, just making sure. Oh, snap. 2 numbers that multiply to 45 and add up to 14. It's the same numbers again. That's just coincidence. Coincidence. That does not always happen that way. It does not always happen that way. Please be aware of that. T chart, 5 and 9, 5x and 5x. Simplify that sucker down. It's an x plus 1 and a 5x plus 9. Now, what that means for us is that this original problem up top factors to be an x plus 1, 5x plus 6 over x plus 1, 5x plus 9. And yes, the x plus 1s cancel each other out. However, nothing else does. It's weird to think of it in this way. It's weird to think of the answer as just being, well, it's a 5x plus 6 and a 5x plus 9. But Ms. Markey, the 5x's, I know, but I can't touch the 5x's. I can't touch the 5x's because the 5x's are being separated by addition. 5x plus 6, 5x plus 9. What about the 6 and the 9? They both have a 3 in common. I'm sorry, can't do it. They're being separated by a plus sign as well. If there is a plus sign or a minus sign separating the term from the rest of the problem, I can't cancel things out the way I want to. That is the answer. If I go back to the quizzes, where was that question? It was up here. There it is. You can see right there, the answer was indeed A. 38% correct. Average time, 10 seconds. That's heartening. Oh no, I messed up. That's disheartening. We have to be careful and methodical with these problems. This problem required the Tucker method. I have a problem that I want you to write down that is not on the quizzes. I have a problem that I want you to write down that is not on the quizzes. Example, x minus 6 over 6 minus x. I want you to ponder this one for a moment. I want you to ponder this one for a moment. Does the top match the bottom exactly? It does not. It does not. They do not match each other exactly. This problem is designed to mess you up. This problem is designed specifically to mess you up. Because even though the top does not match the bottom, there is still something that you can double check to make sure that you're doing it correctly. There's still something that you can check. Now, this is a positive 6, just so you know. This is a positive 6, the one that I'm pointing to. and this is technically a negative x. Please be careful. I'm going to rewrite this problem. I am going to rewrite this problem. Because sometimes people don't listen to the first time. Yeah. Sometimes when I tell my son things and I say something directly to his face and then I pause for half a second, he says to me, wait, what'd you say? I'm like, yep, 7. Also, dramatic effect. You know, sometimes I read the stage directions where it's like, say this with emphasis and dramatic effect with a twinkle in your eye. Exactly. That's what I have to do sometimes. Look what I just wrote. Oh, you can't see it. It's frozen like my heart. There it is. Look what I just wrote. I haven't changed the problem. I have not changed the value of this problem whatsoever. The only thing that I've done is I've switched the positions of the x and 6 on the bottom of the fraction. But that is why I emphasized to you the fact that that 6 was positive and that x was negative. Because when you actually switch their positions, it is a negative x plus 6. Now, still, nothing cancels out. Why are they yelling in my hallway? Is that how she talks? Never mind. Back to this. Look what I'm about to do here. What in the heck did I just do? We're getting there. What do you mean? What you're saying in general is correct. It's just that if somebody heard that sentence, they may not know what the heck you were talking about. No, but here's the deal, though. You do know what you're referring to. What I did was I took out a -1 and treated that -1 as if it were the greatest common factor. That is what I did. I took -1 and I divided both of these terms by -1 and left that -1 on the outside as a greatest common factor. Now, what do you notice about the top of the fraction and the bottom of the fraction? Yeah. Now they can cancel. Yes. Technically, it's +1 over -1, which is just -1. That's what the answer ends up being. This problem is designed to mess you up. Kelsey asks, how did I take -1 from the top? I didn't take -1 from the top. Maybe the glare is in the way. Let me move that over a little bit. There we go. But I took a -1 out of the bottom of the fraction as if it were the greatest common factor. Technically, I could have taken -1 out of the top of the fraction. It just would have gotten the same answer, just in a slightly different way. Check this out. I could have done it this way. X minus 6 over -x plus 6 equals -1 parentheses -x plus 6 over -x plus 6. I could have done it that way. It's the same exact answer. Still ends up being -1. But we got to be careful with how these things kind of cancel out. I love it. How were you taught to add fractions? Now that's the key, though. Common denominator. Common denominator. That's the key, though. Common denominator. I know, right? See, the thing is, it has been like, how many years since you guys have had to like legit like add fractions together and make common denominators? I lit like 4 years. So like at least like middle school then. Holy crap. It has been a while. It's like basically like, hey guys, remember that skill that you learned like many years ago that you haven't used since? It's coming back. Yay. Now, multiplying and dividing is still going to be a thing. We're still going to get practice with multiplying and dividing these things. We absolutely will. I wanted to show you that one example just as a trolling type problem, just to show that things can still be simplified if need be. But now back to our notes. Adding and subtracting rationals. Adding and subtracting rationals. I could do something like this. 2 over x plus 3 over x. And I would say, hey, simplify that thing. And what would you tell me? There it is. Yay, we did it. 5 over x. That was nice. That was straightforward. Yeah, that's the answer for that problem. See, the thing is, when you are adding or subtracting rationals together, as long as they have the same denominator, you got it. Good. There it is. You can add them together, in which the denominators stay the same, and you simply add the numerators together. That's middle school math from back in the day. But now what if I showed you this? 2 over x plus 1 plus, give me a single digit number that's not 1 or 2 or 3. Sure. Plus 5. Now this, I can't do the same way. This, I'm going to have to take an extra step. What is the denominator on that 5? What is the denominator on that 5? Technically, yes. It's a 5 over 1. Do they have the same denominator? No, they do not. But I still have to add them together. I still have to simplify them. Oh, crap. How did you do this back in the day? You failed? Like back in the day, I'm just going to put a problem up here just for funsies. Back in the day, let's say that you had a problem like, I don't know, like a 2/3 plus 1/5. How would you add those together back in the day? Okay. So what would I do? It doesn't become that. Yeah, I see what you're doing. You're finding the common denominator, which is 15, I agree. But then where you lose me is where you just add the 2 and the 1, because you can't do that. Yes, but I can't do that, because I am going to have to do this. I agree that the common denominator is 15. I'm going to have to change both of those fractions.
Wait, isn't it like where it's like 5, 15 is 3, so it's like 3 times the numerator. So it's 3 over 15, and then 5 times 2 is 10 over 15, and then you add that.
That's what you would have to do. That's why I'm trying to remind you. When you find the common denominator, which he's right, it is 15 here. It absolutely is. You are going to have to modify what the fractions look like in order to reflect that common denominator. So in this case, for example, if you want to get 3 to 15, what do you have to multiply by 5? But then you got to multiply the top by 5 as well in order to, well, technically you're 2/3 times 1. But no, 2/3 times 5 over 5 is 10 over 15. Same thing over here where I would have to multiply by 3 over 3, and it would become 3 over 15. And once I have that common denominator, again, 7th grade, I don't know if you learned any of it before then either. I don't know. It's been a million years since anybody remembers any of that stuff. Ah, my calculator. Final answer becomes 13 over 15. This thing got turned. There we go. So that's what I was saying. I know you were just adding the numerators together, but I couldn't do that. I had to do this extra little step here. Up here, I didn't have to worry about it because they both had the same denominator. And since they both had the same denominator, boom, 5 over 15, done and done. But now with this next problem, I'm going to have to take an extra step. With this next problem, I am going to have to do a little bit extra. I see comments in the chat that I haven't looked at. I apologize. What you say? Find a common factor between the two denominators, then multiply them so they're both the same, and then also multiply the tops. Yeah, that's what I'm going to have to do here. Now check this out. Look what I just did here. Technically, I have multiplied by 1 because x plus 1 over x plus 1 cancels each other out. But I'm doing this in such a way where I can force the denominators to be the same thing. The first fraction, I'm not going to change, but the second fraction becomes this. Look at that second fraction. The first fraction is not changing, but the second fraction did. Because I had to multiply it by an x plus 1, as she's saying in the chat right there. Find a common factor between the denominators, then multiply them so they're both the same. And yeah, I multiplied that second fraction in order to get it to be the same denominator. And multiply the tops as well, which I did. 5 times x plus 1 I had to distribute. Do I now have common denominators? The answer is yes. Yeah, you did it. Yay. You now have common denominators. Now you have denominators that are the same, which means I can add the numerators together. This is weird. This is awkward. This is terrible. But this is what we're going to have to do. Say who and the what now? Ah, gotcha. Well, I always treat math as if it were an onion. You know why? Yeah? And it has layers, like an ogre. I know, right? Ogres have layers. I like a parfait. Nobody gets me. You guys seriously never watch Shrek? Okay. That hurt my heart.
We heard you. We're just not laughing.
Ah, that's okay. I'm laughing at myself. Probably not. Can you guys? Go for it. No, you just said that you could, though. I said I couldn't. You said you could. That's pretty good.
It's like a weird Scottish accent.
Yes. Fun fact. Mike Myers was not supposed to be the original Shrek. Chris Farley was before he died. Chris Farley had actually recorded audio for more than half the movie. Then he died, and Mike Myers came in to re-record. But then Mike Myers had recorded maybe a quarter of the movie and decided, no, I think I need to do this in a Scottish accent. And so he basically, the studio had to pay $5 to $10 million for them to scratch all the previous audio and redo it. Yeah. Well, Shrek is now a lifelong franchise. Just saying. Also, he stole the accent from this movie that he did back in the 90s called So I Married an Axe Murderer. Let's try another one. Yeah, hers was much better.
That was like the Scottish.
Let's try this. 3 over x plus 1.
I don't know Mike Myers and Shrek.
Yes. Plus 4 over x plus 2. Now, that's a weird situation. They do not have the same denominator. They don't. This will be the last problem we do today. I'm going to focus all of my attention on this one. They do not have the same denominator, but we can force them to have the same denominator. Forcing them to have the same denominator would be something like this. I'm going to take this first fraction, and I'm going to put this in a different color so you can see it. And I'm going to multiply the top and bottom of the fraction by x plus 2. By multiplying the top and bottom, I'm not changing the value of the fraction. I'm just changing the way that it looks. Changing the way a number looks, or an expression, doesn't necessarily change the value. Can you give me a fraction that is equivalent to 1/2 but is not 1/2? Yeah. It's the same value. It just looks different, right? That's what I'm doing here. It's the same value fraction. I'm just changing the way it looks. Then the second fraction, there's the plus sign. The second fraction, I'm going to do the same thing, but I am going to multiply by an x plus 1 over x plus 1. Again, not changing the value of that fraction, but changing the way that it looks. Now, in a moment, I'm going to start simplifying some junk together, but please note what the heck is happening here. This first fraction will now have the denominator of x plus 1, x plus 2. And this second fraction will have the denominator of x plus 1, x plus 2. By doing this multiplication in such a way, you are forcing both fractions to have the exact same denominator. You just have to simplify up the top a little bit. That's what I'm going to have to do. I'm going to have to multiply the tops, and then add them together. After I simplify just a fraction at a time. Oh, sweet. Kelsey says she watched Shrek last night. Oh. This first fraction would be an x plus 1, x plus 2 denominator, but simplifying it, I'd have to distribute that 3 and get a 3x plus 6. The second fraction would have the exact same denominator. Distributing that 4 would be a 4x plus 4. Adding fractions or subtracting fractions, you have to have the same denominator. And when you add them together, finally, you combine them into a single fraction. That denominator remains, but then I just have to combine like terms on the top of the fraction. This is where I would get a 7x plus 10. Sometimes you can simplify these things farther, but this one you can't, and we're not going to worry about that today. But this is the process that you guys would have to go through. Now, this is just a small step. This is just a small introduction to this concept of adding and subtracting rational functions. But we are going to be spending the next couple of class periods practicing and reviewing multiplication division and practicing and learning this new concept of adding and subtracting. It's going to take a little bit, but we will get there. Again, if you haven't left a comment in the chat, please make sure that you do so, number one. Number two, if you owe me anything before grades are to be submitted on the 15th, make sure that you are contacting me about that, as several of you have done. And we will see you on Thursday, because the bell is going to ring about now. Half a second off. You know what movie sucked? Shrek 3.